prime, and composite numbers. Prime. A prime number has two factors only. One and itself. Composite. Has more than two factors. Okay, so a prime number has two factors only, one and itself, and a composite number has more than two factors. Okay, we're going to discuss the basic prime and composite numbers between 1 and 20. Now, 1 is neither prime or composite because 1 only has one factor itself. 2 is prime because the factors of 2 are 1 and 2. And by the definition, having factors 1 in itself and 2 factors, it's prime. So we can use P for short. 3, 1 and 3 as factors, so it's also prime. 4 is composite because it has 1, 2, and 4. So it's composite. 5, it's prime because the factors are 1 and 5. 6 is composite. 1, 2, 3, and 6. As factors, so it's composite. 7 is prime. Just 1 and 7 as its factors. 8 is composite. 1, 2, 4, and 8. 9 is composite as well. 1, 3, and 9 has factors, so it's composite. 10 is composite. 1, 2, 5, and 10 are the factors of 10, so it's composite. 11 is prime. Factors are 1 and 11. It's prime. 12, 1, 2, 3, 4, 6, and 12. So it's composite. 13, 1 and 13 are its factors, so it's prime. 14, you have 1, 2, 7, and 14, so it's composite. 15, we have 1, 3, 5, and 15, so it's composite. 16, we have 1, 2, 4, we have 8, and we have 16, so it's composite. 17, we have 1 and 17, so that's prime. 18, we have 1, 2, 3, 6, 9, and 18, so it's composite. 19, we have 1 and 19, so it's prime. And 20, we have 1, 2, 4, 5, 10, and 20, so it's composite. Okay, it's very helpful to know these basic facts between 1 and 20 for further study of prime and composite numbers. Okay, now we're going to study a prime factorization. Okay, a prime factorization uses what we call a factor tree to get all the primes of a particular number. For example, let's say if I want the prime factorization of 20. I choose any numbers I can multiply by to get 20. So I can choose 2 times 10. Now 2 is prime, so I cannot break it down any further, so I circle it. That's my first prime factor. 10 is composite, so that means I can break it down further. So 2 times 5 is equal to 10. So 5 is prime. 2 is also prime. So this is what I call my factor tree. All right, now I'm gonna concentrate on my primes. So prime factorization of 20 is equal to 2 times 2 times 5. All right, 2 2s are 4, 4 5s are 20. Now we can also use exponents, all right? 2 to the power of 2, because I have 2 2's, so 2 squared, or 2 to the power of 2, times 5. This is my prime factorization of 20. Or here. So this version is called expanded form. And this version is called exponential form. Okay, let's take another example. If I want a prime factorization of 100. Now it doesn't matter how I start breaking down 100, I will always end up with the same primes. and we can take a look at that. So let's say I can break down 100 with 10 times 10. So 10 is not prime, 10 is composite, so that means I can continue breaking it down. I have 2 times 5, 2 and 5 are prime, and I also have 2 times 5. So 100 is equal to 2 times 2 times 5 times 5. Or we can also say this is the multiplicative expanded form, or we can say using exponents 2 squared, because I have 2 2's, times 5 squared, because I have 2 5's. So 2 squared, 2 times 2 is 4. 5 squared, 5 times 5 is 25. 4 times 25 is equal to 100. Now let's suppose somebody decides to break up 100 differently. Let's say we can start off with 2, because a 100 is an even number, so 2 is prime. 2 times 50. I can use 2 again. 2 times 25. 2 is prime again, so we break up 25. 5 times 5. So we still end up with the same amount of prime factors, 2 2's and 2 5's, just like the previous factor tree. So it doesn't matter how we start, our result will be the same.